Hello students, here is a problem on simple harmonic motion, and the question is good for IIT aspirants and also it is good for NEET students, NEET aspirants. The question is, here is a parabolic shaped wire which contains a bead inside. A bead is this and there is a parabolic shaped wire, and the bead can move along the wire, it can move back and forth. The equation for this parabolic wire is y is equal to alpha x square. It is a equation of a parabola. और इस चीज का जो इक्वेशन है वो y is equal to alpha x square. And now, initially the bead is here at the bottom, and if you push it slightly by a smaller angle, a smaller displacement, we have to prove it oscillates back and forth simple harmonically. And then we have to find also the time period of those simple harmonic oscillations. Have a pause for a moment and think about the problem. Later, when I solve the problem in a few steps, then you say it is very easy. पहले आप खुद करने की कोशिश करो, फिर solution देख लो. तब आपको पता चलेगा it is a standard problem and it can be asked at IIT level or it can be asked for to the NEET students. Because अब वो जो लाइन था NEET और IIT के दरमियान जो लाइन था, that is now blurred, that is over. Any question can be asked in the basic physics to the NEET students or to the IIT students. So how to start it? First, step number first. Okay, let me go through steps. Step first. Step first is I have an equation about this parabolic wire, that is y is equal to alpha x square. If I differentiate this y with respect to x, what I get? dy by dx is equal to 2 alpha x. This is differentiation of y with respect to x. But here differentiation of y with respect to x is slope of this parabola. At what position? At what position this is the slope? At position, any position that is y, which is x. At this position, it is the slope. For defined x, for defined y, its coordinates are x and y, and its slope is dy by dx equal to 2 alpha x. And this slope is nothing but tan theta. Also, it can be equal to sine theta for small theta. For small theta. If I put a tangent here, if I make a tangent here like this is theta, and tan theta of this line is the slope. Tan theta of this line is the slope. So I got a slope, I got tan theta, and also I got sine theta. Now, let me find what are the forces on this bead here. The force is first of all mg downwards. There is also normal reaction in this direction. Leave that aside. And this mg, if it's theta, it is 90 minus theta, it is again theta. Theta, it is 90 minus theta, and this remaining angle is theta. And mg can be resolved into two components. Here it is mg cos theta in this direction. And what's the restoring force along the parabola or along this wire? How much is the restoring force? That's mg, it is cos component, it is sine component. So restoring force is equal to minus mg sine of theta. It is step number second. Okay, now F is nothing but ma according to Newton's law, mg sine of theta. Is that right? Restoring force, component of mg along this line, along the parabolic path, and mg cos theta will be balanced by the normal reaction, or normal reaction is opposite to the mg cos theta. That is we don't need to go to these forces, because these are not the forces which are responsible for getting it back to the mean position. In force का ये नहीं है contribution to get it back. It is only this force to get it back to the mean position. Okay, now m gets cancelled. So a is equal to minus g. What is the sine theta? That is 2ax, 2 alpha x. Right? So a is equal to minus 2g alpha x. Now recognize the equation. Recognize the equation. You do have what you call as simple harmonic motion equations. One of the equations is a is equal to minus omega square x. Wherever you find equation of in such standard form, that means the particle oscillates back and forth simple harmonically. ये इक्वेशन का मतलब ही है कि it oscillates back and beat oscillates back and forth simple harmonically because this equation resembles the basic fundamental equation of simple harmonic motion. So what should be omega square equal to? Omega square should be equal to 2g alpha, and omega is equal to root of 2g alpha. First of all, we have proved that it is simple harmonic motion. How did we prove it? हमने कैसे प्रूव किया? क्योंकि ये जो इक्वेशन हमें मिला, it resembles one of the standard simple harmonic motion equation. इस इक्वेशन को देखते ही पता चलना चाहिए कि पार्टिकल ऑसिलेट्स बैक एंड फोर्थ. वजह क्योंकि ये जो इक्वेशन है ये हमारे सिंपल हार्मोनिक इक्वेशन के साथ मैच होता है. It matches the standard equation of simple harmonic motion. तो इससे हमें सीधे सीधे ये ओमेगा स्क्वायर मिला. अच्छा, now what about t? You know omega is 2 pi by t. तो यहां से हमें t मिलेगा. तो how much is that? Time period. What is the time period of this particle going back and forth like this? So time period is equal to 2 pi, this इसका उल्टा 1 by root of 2g alpha, ऐसे कुछ. So you can take it as an answer. यही आंसर लिया जा सकता है. So it was a problem of a good standard, but I did it in a very simple two steps. Now it seems to be quite easy, but you must know if y is here, you can find the slope, and you can find the geometrical slope from here. You can compare the two and get the answer. Thank you. Continue to watch my lectures on YouTube. I am uploading lectures every day, and I will also upload lectures for 11th, for 12th, for entrance. All the lectures will be on YouTube. You just follow the YouTube channel and you don't need to go anywhere else to learn physics. Thank you.